Hi guys, I'm Mitchell,
And my name is Max.
and today we're going to be giving you a 101 physics lesson on electricity.
Our first topic we'll be talking about is differences in electric potential.
We started by creating our circuit. We connected one wire to the positive terminal of the batteries and one wire to the negative terminal of the battery. We then took the positive wire and connected it to the positive side of the capacitor, and then the negative wire and connected it to the negative side of the capacitor. When we took one of the metal clips and we touched it to both the negative and positive side of the capacitor, we experienced a spark.
Now that brings us to the question, what is the physics behind the spark? Here's the answer. The positive terminal and the negative terminal of the capacitors are both at a different potential. This is because the positive terminal has a positive potential and the negative terminal has a negative potential. You can visualize this by thinking of a hill. The positive potential is the top of the hill and the negative is the bottom of the hill, or a well. As charges move down the hill, they speed up, causing them to let off energy. So when we close the circuit by connecting one wire to both capacitors, the hill is formed and the excess amount of electrons speed up, causing a spark. For a real-world example, electricians always have to be on the same potential as live wires, or else they will be electrocuted. That is why they cannot touch the ground while working on wires, because of the potential difference. Overall, if you touch a live wire without being on the same potential, you will look like you just got the Albert Einstein cut.
The next topic we will be going over today is how energy applies to the capacitor and the spark it makes. To get started, we drew the setup of the capacitor and the two wires. Now let's start with the law of conservation of energy. It states that energy cannot be created nor destroyed. Energy can only be transferred in and out of a system to another system by working. We next drew an energy flow diagram, or an LOL diagram. The center circle of the LOL represents our system. In this case, our system was wire 1 and wire 2. The L's of the diagram were a picture of energy being transferred. This helps us to understand where the energy was transferred between wire 1 and wire 2. In this model, it shows that once the wires touch together, the electric field is so strong that some of the energy that was originally stored electrically transferred into the air by working. This transfer of excess charge is what causes the spark. Energy is still being stored too. The 4 boxes that were originally all in the electric storage are now divided, with 2 boxes as electrical energy and 2 boxes being transferred out of the system.
Another example of stupidity and examples of energy flow and electric potential is me shocking Jack in the butt. In the video, Jack is holding on to the Venn diagram generator, which gives him more electrons, which therefore gives him a negative potential. So therefore, when I touch him, there's a potential difference causing me to shock him. Another way to explain this is by creating an energy flow diagram. In this case, Jack would be our system. Before I touch him, all of the energy in him is stored electrically. So let's just say 4 boxes. And then after I touch him, causing that shock and transfer, all that energy is transferred to me via working. This shows a conservation in energy, with 4 boxes being out of the system.